Hi and welcome to Axiom Chemistry. In this video, we're going to talk about change of state. As you know, in Axiom Chemistry, we're going to be thinking about the three common states of matter. Solids like this rock here, liquids like this water here, and gases like those you can see pouring out of the top of the volcano. As you should remember, the particles are arranged differently in these three states. So in solids, like ice, the particles are packed closely together in fixed positions. So solids have a fixed shape, and those particles can vibrate, but they can't move more freely. In liquids, like water, the particles are still packed closely together, but this time not with fixed positions, so those particles can slide past each other, and so liquids, of course, don't have a fixed shape. And finally, gases. In gases, the particles, as you know, are spread far apart, and so they can move in all directions and fill the available space. An example of a substance in the gaseous state is steam, like the steam you can see coming out of this kettle here. Now, let's think about how a substance can change from one state to another. Well, I'm sure you know that if you take ice and you heat it, well, you're going to form water. And if you take water and you continue to heat it, you're going to form steam. And then if you can catch that steam and cool it, well, you're going to form water. And then if you cool that water even more, you're going to once more form ice. Now, these processes have technical names and they're probably very familiar to you. Melting, boiling, or evaporating. We'll talk about the differences between boiling and evaporating later on in this video. Condensing and freezing. Let me show you that on a diagram. I've got solid, liquid, and gas. I'm going to mark processes where the energy is going in, so heating in purple, and processes where energy is going out, so cooling in green. So first of all, if we start with a solid and we put energy in, we heat it, well, as we've just seen, you can form a liquid, and that process is melting. If you continue to put energy in, you'll form a gas, and that's boiling or evaporating. If you go the other way, if you take energy out or cool, that's condensing and you'll go back to the liquid. And then if you continue to take energy out, you'll go from a liquid to a solid, and that is freezing. That's what we already discussed just a minute ago, but it does raise a question. Can substances ever pass from the solid to the gaseous state without passing through the liquid? So, like this. Well, the answer is yes, and it's called subliming, but it is quite unusual. One example of a substance which does this is dry ice or frozen carbon dioxide. The solid carbon dioxide looks like it's smoking, and the effect can be quite dramatic. It's sometimes used as a special effect in theatres and concerts. The reverse process, so going directly from a gas to a solid, is called reverse subliming. Now, all of these processes just change the physical state of the substance, and so they're called physical, not chemical, changes. Okay, now let's think about these physical processes in terms of the particles themselves. So let me sketch some particles in a solid. Here they are in nice, neat rows. Now, when they're heated up, they gain energy, so they start to move faster and faster with more and more energy until they finally break away from their fixed positions and slip and slide over each other. And of course, at that point, they've melted. And the temperature at which a solid melts is called the melting point. A high melting point means particles are strongly bound together, like in a metal. And a lower melting point means that there are weaker forces attracting the particles together, so perhaps in ice. Okay, what happens if we continue to heat up these particles? Well, of course, they're going to gain energy and move faster, and eventually they'll have enough energy to break away, and they'll behave like a gas. That's, of course, called boiling, and the temperature at which a liquid boils is called the boiling point. Incidentally, a gas is a substance which is in the gaseous state at room temperature, like oxygen. If a substance needs to be heated for this to happen, we call it, when it's in the gaseous state, a vapour. So steam is actually a vapour. But very often people will just call any substance in the gaseous state a gas. Okay, just before we end this video, I want to go back to the difference between boiling and evaporation. So here's an example of something that's been boiling. And here is an example of something that's evaporating. Now, at any temperature, the particles of a substance are moving at a variety of speeds and have different amounts of energy. At the boiling point, or above it, all the particles have enough energy to break away from the liquid. And so this is steam here, and that water has boiled. All of the particles have enough energy to break away from the liquid. Evaporation happens when only some of the particles at the surface of the liquid have enough energy and are moving fast enough to break away from the others. You can see some particles evaporating from the hot coffee in this picture. You can see them up here. These particles have enough energy to break away, but not all of the particles in here, in the coffee, had enough energy to do that. Evaporation happens even at room temperature water, or even in cold water like these puddles, because even at these lower temperatures, some particles will have enough energy to break away from all of the others. Okay, as ever, here is a summary of what we've discussed in this video. The diagram shows the physical processes which connect the solid, liquid and gaseous states. We've also seen that the melting point is the temperature at which a solid melts, and the boiling point is the temperature at which a liquid boils. And finally, we've seen that even below the boiling point, some particles in a liquid will have enough energy to evaporate. If you haven't yet written any of that down, I suggest you pause the video and do that now. Well done, and see you in the next video.